So we'll go through these steps. We'll start off with the NX integration. So some of the key points that I want to explain here, and then we'll show you how it looks, is that first of all, again, it is embedded, so it's just another application in NX. So if you're an NX user, you go to the application toolbar and launch the FloEFD application. Just like any other application in NX, you'll get a ribbon bar that has all the FloEFD functions that will be available without spawning another process with another interface. So it's a very familiar environment for anybody that's using NX already. I mentioned before that when we apply the conditions, boundary conditions, materials, all those things that we need to have for the analysis, it's done directly to the CAD geometry. So there's no translation, no conversion, there's no separation of geometry between the two. And one of the great benefit is FloEFD has the ability to detect the volumes within an assembly, and we'll take a look at that. So what you see on the screen right now, the light blue volume there is determined from automatic volume detection. So it looks at, then this is an assembly. It might be hard to see at this point, but I'll show you in the demo what this assembly looks like, and all the open space between the parts is going to be recognized and potentially treated as the fluid volume. So let's take a look at what this might look like. This is an assembly of, let me make sure I get this right, it's an IGBT, which stands for an insulated gate bipolar transistor module. So it's something that you'll find in an electric vehicle. So let's take a look at here. This is an exploded view of the assembly, so it shows all the electronic components. And on the left-hand side, you'll see the just your normal assembly structure. So we've got all the components modeled here in the assembly, starting from the case, the seal. There's an O-ring that's sort of a rectangular shape down towards the bottom. There's a base plate that has some cooling pins. We'll take a closer look at that in a moment. And then chips and chip carriers and things like that. Even the adhesive layers are defined here. Anything that has a material that's going to affect the analysis is defined here in the assembly. So the things that you can do here is work with your normal NX assembly. For other purposes, you might choose to use materials that are from the library within NX, but you don't necessarily have to do that. You can assign materials within FloEFD as well. So here's the base plate, and if we take a look at the base plate features there, it's going to be a typical NX model. Nothing special about it. It's got, as you see, a series of pins in here that are arranged in a pattern, and of course, these are going to be serving as the primary methods of drawing the heat away from the electronic components here. Now, we might want to do some optimization. One of the steps that we talked about is design exploration or optimization. So this particular assembly has some specific parameters that we might want to modify later on. So there's the diameter of the pins, the draft angle of the pins, the pitch of the pins, and maybe early on in the design you're not quite sure if this is the best arrangement, the quantity, the spacing, all that, the sizing, but that's what we're going to do the analysis for. We want to find out what we can do to make this thing perform a little bit better. So those are going to be some important parameters that we'll take a look at a little bit later on. Now we can also take a look, if we do a standard cross section with NX and zoom in on something here. If you're an NX user, you might be familiar with things called deformable components within NX, where you have things like seals and springs, things that change shape when you install them. And that's typically a concern when you're doing some kind of analysis to get the geometry representation as accurate as possible. With FloEFD, you don't necessarily have to worry about that. So this is an example of where you have a seal that's going to be compressed in a groove. The FloEFD can handle overlapping geometry. It takes a look at a material priority that you give it. So if you have, for example, a metal and a rubber overlapping, of course the metal's probably going to take priority. So you don't have to necessarily go through the entire assembly and resolve any kinds of interferences like something that you see right here, because FloEFD can handle that using those materials priorities. So it'll save you a lot of time and just having to tweak every little thing, and especially in a complex assembly, it gets pretty time consuming. Okay. So we're going to go ahead and launch FloEFD. Like I said, it's another application. And you get a toolbar that you'll see up here towards the top. So in this toolbar, you have the ability to create projects. If I just kind of go from left to right, you got the project options towards the left, setting up your boundary conditions and the goals that you want to use for your analysis. So they can be something like temperature goals or pressure goals. You can apply them in different ways. We'll talk about that. And if you kind of go from left to right there's a meshing step, which is fairly easy to do, solving, and then, okay, of course, looking at the results. Now, before we even get that far, though, there are some specialty tools that we want to take a look at. So over to the right there, we can cap off any openings by using a function called create lids to automatically cap the ends of our assembly. And then we can also, like I said before, have FloEFD automatically detect all the spaces, all the kind of gaps between the parts. And you can see here in the blue, those are the areas that got detected. If you take a look at the dialog I've got on the screen right now, there is an option that says exclude cavities without flow conditions. So even though you might have some spaces within your assembly that exist, if they don't participate in the analysis, once you define your conditions, which we'll do in the next step here, you don't have to worry about it. You just tell FloEFD to ignore those things. So we've got this set up. We'll go ahead and accept this. Again, the ends are capped off automatically with the create lids function. So there's a couple lids that you see that got added to the navigator, lid 1 and lid 2. Okay, so let's move on here. So just kind of summarize what we talked about there. There was very little work that had to be done to the NX assembly. We just used it pretty much as is and used some automated tools within FloEFD to detect some of the important things that we wanted to have added, like the fluid volume, the end caps on the areas where we want to have the fluid either entering or exiting the assembly. So again, using the natural NX geometry, we're going to be able to make some changes and have the analysis update. So we're looking forward to doing that here towards the end of our discussion here.